Okay, so this is question 8, which is a binomial expansion, where we need to identify a specific term, and the term is the x squared term. So we're going to be expanding 3x plus 1 to the power of n. Now, the first thing you need to do is kind of either identify the full expansion, or at least think about this. The expansion is going to be nr, that's ncr. Then you're going to get 3x to the power of r and 1 to the power of n minus r. Now, 1 to the power of n minus r is always going to be a 1. 3x to the power of r is going to just be going up. So it's going to be, the first term will be 0, the next term will be first term will be 1, the next term is 3x, the next term is 9x squared, 27x cubed. And this is our governing kind of coefficient, so that's the NCR bit. We could write this as ... Okay, so you could start n0, 3x to the power of 0, 1 to the power of n, n1, 3x to the power of 1, 1 to the power of n minus 1, and then n2, 3x to the power of 2, 1 to the power of n minus 2. You don't need to write this full line. What you could do is write in just this. This whole thing we know is always going to be 1, that's the first term, plus n1, that's going to be n, from Pascal's triangle 1n, and then that's going to be 3x, but we don't need this term, plus n minus 1 over 2 times 3x squared, ... This is the term we're looking for, so we need to see that you've identified that. So the coefficient of that is going to be 135n. So we can kind of ignore the x squareds and form this equation. n minus 1 over 2 times 3 squared, which is 9, is equal to 135n. And I've got rid of the x squared from this, and this is the coefficient, 135n. So 9 does go into 135 because 5 plus 3 is 8 plus 1 is 9. So you could do a little quick division, 135 divided by 9. I think that looks like 15. 9 into 13 goes once, remained 4. 9 into 45 is 5. 9 times 15. So n minus 1 is equal to 15n. That's over 2. n minus 1 is equal to 30n. I could divide both sides by n only because, there we go, it was off screen. I could divide both sides by n only because you will find that n cannot be equal to 0. So one pathway would be to do this, cancel off the n's and say n minus 1 is equal to 30. So n is equal to 31. If I wanted to be a little bit more formal with this, I could say that from this line I could write n squared minus n equals 30n. N squared minus 31n equals 0. N bracketed n minus 31 is equal to 0. Therefore n could be equal to 0 or 31, and n cannot be equal to 0, so we can put a cross through it. And using this quadratic approach means you do not lose any potential solutions. I think that is about it. We found n is a positive real number. Perfect.